You might remember that a standard IP access control list could filter traffic, it could permit or deny traffic based on source address information. Well, an extended ACL can pay attention to both source and destination address information. Let's see if we can configure this scenario. On router R1, we want to set up an extended, and specifically this is going to be an extended numbered access control list as opposed to a named, which we'll take a look at in the next video. But we want to set up an extended numbered access control list to permit traffic from PCA to server 1, but not to server 2. And as far as PCB is concerned, we don't want PCB to be able to communicate at all with server 1, but it can communicate with server 2, but only using the HTTP protocol. How can we set this up? Well, we're going to begin by creating an extended access control list, much like we did when we created a standard access control list, but a standard access control list had a number in the range of 1 through 99. Well, our extended access control list has a number in the range of 1 through 199. And we're saying access list 100 permit, and we're saying what protocol we're permitting. We're going to be permitting all IP traffic. The source is going to be the host with the IP address of 10.1.1.101, that's PCA, and the permitted destination is the host of 192.168.1.2. And notice that I'm using the host keyword here and specifying a single IP address. Instead of doing that, we could specify a subnet, followed by a wildcard mask for that subnet. But here we're being very specific, saying this host can get to this other host. And this is allowing PCA to talk to server 1, and if I don't say it's allowed to talk with server 2, that's implicitly going to deny it. Remember, we've got this deny any statement down at the bottom of our access control list, so PCA will not be allowed to talk with server 2. What about PCB? PCB, it should only be communicating with server 2 using the HTTP protocol. To set that up, we're going to say access list 100 permit, and here I'm being a bit more specific. I want to permit a specific protocol, and that protocol is TCP based, so I say permit TCP. What's the source? It's the host of 10.1.1.102, and the destination is going to be 192.168.1.3, but notice I'm using the keyword of EQ and then www. I could use a port number there. I could say EQ80 because that's the common HTTP port that we use, but instead I'm using a Cisco IOS keyword of www, which means HTTP traffic. And of course you could use context-sensitive help to see what protocol names are supported there after the EQ. Now that we've got this access control list created, we need to apply it. Let's go into interface fast Ethernet 0/0 and say IP access-group 100 coming into router R1. Let's go out to our live gear right now and confirm that this really works. Before we jump into the configuration, let's confirm that PCA and PCB can indeed communicate without any access control list with our servers. From PCA, let's do a ping to 192.168.1.2, that's server 1, 1.3, that's server 2. Let's do the same thing from PCB, let's do a ping to 192.168.1.2. Success. 1.3. Success. We've confirmed that, initially anyway, our PCs can communicate with our servers. Now let's go to router R1 and set up our access control list. Let's go into global configuration mode and we'll say access-list, and context-sensitive help is showing us that an extended numbered access control list has a number in the range of 1 through 199. We're going to say access-list 100 permit, and we can permit specific protocols. I want to permit all IP traffic for PCA to go to server 1. So we'll say permit IP from a source of host 10.1.1.101 to a destination, which is a host of 192.168.1.2. That's server 1. Let's enter another access control entry, or an ACE, an ACE, that's going to permit HTTP traffic from PCB to server 2. We'll say access-list 100 again. Permit. This time I want to be very specific. I want to permit a specific TCP protocol, HTTP traffic specifically. So we will say permit TCP, where the source is host 10.1.1.102. That's PCB. The destination is host 192.168.1.3, and I'm going to say EQ for equals. And you see that I could specify a port number, or we've got all these predefined protocols that we could use. I'm going to use www, which is HTTP traffic, or port 80 traffic. We'll say EQ www, and let's press enter. We've created our access control list now. Let's apply it. Let's go into interface fast Ethernet 0/0, and we'll say IP access-group 100 coming in to fast Ethernet 0/0. We can give a show command to confirm our access control list. Let's do a show access-lists, and we see we have a couple of entries, a couple of ACs that make up this ACL. Let's make sure it works. Let's go to PCA. PCA should have connectivity with server 1. Let's do a ping to 192.168.1.2. That worked. We should not have access, however, to server 2. Let's try to ping 1.3. And it's unreachable. The access control list is doing its job for PCA. What about PCB? If we go to PCB and try to do a ping, it should fail. Let's try to ping 192.168.1.2. That's server 1. That should fail. It's unreachable. The ping should also fail when we try to reach server 2, and it does. But even though we could not reach server 2 with the ping, we should still be able to reach it using the HTTP protocol. Let's try. Do you remember how we can do that from a router using the telnet command? I can say telnet to 192.168.1.3, give a space and give the port number. I'll say port 80, and it says that it's open. I'll just quit out of this, and we can see that we were able to establish a connection using HTTP with server 2. And this is a basic example of an extended numbered access control list. In our next video, let's take a look at an extended named access control list. Earlier, we learned that a standard access control list could have a number in the range of 1 through 99, and an extended access control list could have a number in the range of 100 through 199. Well, we can also have named ACLs, and this is not just for extended ACLs. We could have named standard ACLs. That's possible. But let's take a look at how to set up an extended named access control list. And many people prefer working with named ACLs as opposed to numbered ACLs. The names can give us an intuitive idea of what is this access list supposed to be doing for us. Let's use the same set of goals that we had in our previous example, and that is PCA, we want it to be able to reach server 1, but not server 2, and PCB, it should not be able to reach server 1 at all, and it should be able to reach server 2 only using port 80, only using the HTTP port. Here's how we can set up an extended named access control list. From global configuration mode, we say IP access-list. Extended, we could say standard. You can have a standard named access control list. That's okay, but here we're doing an extended access control list, and I'm just naming it as CCNA_demo. And a practice that I like to use is when I come up with a name, like CCNA_demo here, I like to use all uppercase when I give a name to something within Cisco iOS. That way, when I'm looking through my config, if anything is in all uppercase, I know that's probably a name that I created. That's not some sort of a Cisco iOS keyword. And notice the new configuration mode we're in now. We're in extended NACL, named access control list configuration mode. From here, we can give a series of permit and deny commands. And to begin with, we're saying permit IP host 10.1.1.101, that's PCA. We're allowing PCA to get to host 192.168.1.2, that's server 1. And we're also going to allow PCB, which is host 10.1.1.102, to get over to server 2 at 192.168.1.3, but only on port 80. Let's exit out of this configuration mode, back to global configuration mode, and jump into interface configuration mode for interface fast Ethernet 0/0, and let's apply this extended named access control list. We say IP access-group, we give the name, CCNA_demo, and we give a direction, which is in. Let's go out to the live interface, enter this in our router, and then let's take it a step further. Let's see how we can edit an existing access control list. Before configuring our extended named access control list, let's see where these PCs can reach right now. From PCA, let's do a ping over to server 1, 192.168.1.2, success. What about server 2? That's 1.3, success. Let's go over to PCB and try it there. Let's do a ping to 192.168.1.2, success, and 1.3, success. Our PCs can reach our servers. Now let's go into router R1 and create an extended named access control list. We begin by going into global configuration mode, and to create a named access control list, I'm going to say IP access-list, and notice that I could say standard here, but we're going to do extended. We'll say IP access list extended, and I could give a number here. Even though this is a named access control list, I could still specify a number. That number could act like a name. But in our example, we were going to use the name of CCNA _ demo. And we're in this new configuration mode. We're in extended named access control list configuration mode. From here, we can give a series of commands like permit or deny commands. And I'm going to say permit all IP traffic from a source, which is a host in our case, of 10.1.1.101 to a destination, which is a host of 192.168.1.2. That is server 1. Let's add another permit statement. I'm going to say permit. This time I'll only want to permit TCP traffic, and specifically it's going to be TCP traffic using port 80. That's our HTTP traffic. So I'll say permit TCP where our source is a host with an IP address of 10.1.1.102. Our destination is a host of 192.168.1.3, but I only want a single port to be able to reach this host. I'll say EQ, and I could give a number of 80, or I could give the keyword of www. And that's the creation of our extended named access control list. Let's go into interface configuration mode now for Fast Ethernet 0/0, and let's apply it. We'll say IP access-group, and we'll say CCNA _ demo. That's the name of our access list, and we want to apply it in the inbound direction. If we take a look at our access control list, we'll see that we have these two entries. We can do a show access-lists, and this is pretty much what we had in our previous example. We've got a couple of statements. The first one is allowing PCA to reach server 1, and the second statement is allowing PCB to reach server 2 on port 80. But let's do this. Let's see how to edit an access control list. Notice these numbers over on the left-hand side. We've got a 10 and a 20. These are called sequence numbers. Remember, we said that an access control list was processed top-down. So we look at sequence number 10 before we look at sequence number 20. What if we had a sequence number 15 that happened to be in the middle? If we had a sequence number 15, it would be processed before sequence number 20. So let's do this. Let's go back into our extended named access control list configuration mode by saying IP access-list extended CCNA _ demo, and let's insert a command between sequence numbers 10 and 20. Let's use sequence number 15. If I give context-sensitive help, you see here is that sequence number. I can say I want to insert with a sequence number of 15 a different command, and I'm going to say deny this time, and I'm going to deny all IP traffic from any source to any destination. And if we go back and take a look at our access control list now, if we do a show access-lists, we see that we now have this new entry that's been injected in between sequence numbers 10 and 20. So what do you predict is going to happen here? I predict that PCA should be able to ping server 1, but nothing else is going to be permitted. As soon as we hit this deny IP any permit statements that occur later on in the access control list, they're not going to be used because any IP traffic is going to be matched by sequence number 15. And as a result, PCB should not be able to reach server 2 using the World Wide Web port. Let's confirm that. Let's go to PCA. PCA should be able to ping server 1. Let's try ping 192.168.1.2. It can. It should not be able to ping server 2. It's unreachable. That's expected. Let's check things out on PCB right now. It should not be able to reach either server, even using port 80 going to server 2. Let's do a ping to 192.168.1.2. Unreachable. 1.3, unreachable. But something that did work previously, we were able to do a telnet to server 2, 192.168.1.3, using port 80. That worked before, but now it says the destination is unreachable. And the reason is we injected this line before we said PCB could reach server 2. And since we're processing our access control list top down, that's going to nullify any permit statements that occur later on in our access control list.